Can we predict earthquakes? Yes and no. They can be predicted on a long term. We know that the plates are moving at plate boundaries. We can say that there have been gaps in the seismic record, and that tells us that we probably are due for an earthquake because the plates are still moving. So we can look at it into tens or hundreds of years. We can't predict it like right now to say that there's going to be an earthquake later today or tomorrow. We like to be able to predict things, though, because they're big hazards and they're deadly. We can map the risk. I'll show you a map in a second. But mapping those risks is important so that we can have building codes. The building codes in Boone are different than the building codes, say, on the plate boundaries associated with the San Andreas Fault Zone. We can also think of it in terms of land use planning. We wouldn't want to put a building right over the trace of the fault. And then we can plan for earthquakes. So in California, they're constantly doing some planning on what's going to happen when the earthquakes happen. We don't do that in North Carolina. We think about maybe when there might be a flood or a hurricane, but not so much an earthquake. So here is that hazard map, kind of a risk map. And these can be a little deceiving, though. So New Madrid is on here, but who's to say that to the north of New Madrid there wouldn't be a big earthquake associated with that sedimentary basin? So New Madrid is highlighted because that's where we've had activity in the past. The same thing with South Carolina. There was a large earthquake in Charleston, South Carolina. Who's to say that that stress hasn't shifted and now it should be a hazard along the coast of Georgia? So, but those are spots that have had earthquakes in the past. This is the East Tennessee seismic zone that's near us in Boone, North Carolina. And that's another area which is not on a plate boundary, but they do experience small, medium earthquakes from time to time. The real hot spot for earthquake activity in the United States, though, is over here along the plate boundary. The plate boundary that is the San Andreas, and then up here with the Juan de Fuca subduction zone. There's also earthquake activity associated with Mauna Loa and Kilauea in Hawaii, and then the subduction zone related to the Aleutian Islands and convergence here pushing into Alaska. So a lot of areas in the United States, not so close to Boone, but where we have plate boundaries, or the hotspot of Hawaii. Looking at it worldwide, are those same places on this map here, and all along the western edge of South America, and then throughout this middle part of the Mediterranean, across, West and East Asia, and then across Asia and into China, and then Russia, and then over to the Ring of Fire, Japan, Philippines, Indonesia, down into New Zealand. So lots of earthquake activity around the world. So we look at places from the past to see, I'm just going to turn myself off here. We look at the past to try to predict what might happen in the future. We talk about in terms of probability. We look at fault motions along, it's like these are ridges coming down and there is a fault scarp. We can look at the age of that fault scarp and maybe think about the timing of the last movement along that fault, and is it still at a plate boundary? Here are some offset streams. We can look at the timing along those offsets, these offset ridges, and talk about maybe times that we haven't had an earthquake in a while, so maybe we're due for one to happen sooner than later. So we look at all this evidence from the past to try to forecast what may happen on the long term. One way we do that along the front of valleys is by looking at sedimentation in these basins and the fault motion and offsets along these old faults in old sedimentary basins. We can go in there and we can find areas that have paleo soils. These are old soil horizons, so that was their surface at some time. Turn myself back on here. Hi. We can get a recurrence interval for when the faults were active, when was there an earthquake in the past, did the faults cut through all of this material, here was a fault that was active and then not anymore. Find some datable wood fragments in there and set up the historic timeline of fault motion that's recorded in a basin, sedimentary basin like this. Once we have kind of that record, then we can map out time of chunks of time when there hasn't been an earthquake and say, okay, this is the normal progression of earthquakes along this fault. We haven't had one in a while, so maybe there will be one coming up, or we had one, so it may be a long time before there's another earthquake. So, yeah, it's not really possible to do short-range predictions. We don't do a good job with that. There can be precursors, to earthquake activity. Maybe there's a cluster of little earthquakes or foreshocks that could make people say, oh, maybe there's going to be a big one coming up. There can be measurements of strain and changes in the shape of the Earth's surface. So we monitor with GPSs the height of the surface, or maybe it's dropping down, and that could be a precursor to an earthquake. If there is, usually you're going to need more than one, like a well that is a municipal well or a drinking water well. They can look at the level of the water. The water table can change heights. And that would be the result of maybe cracks opening up related to those foreshocks and water draining away or flowing into another place. Gases also can change as cracks. Those little micro cracks form. Maybe a gas buildup would occur inside a municipal or drinking water well. Animals also can act crazy. Chickens will fly. Dogs will bark, 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 bark. And that has been noted to happen just before earthquakes occur. One story that's told is that of the Haiti earthquake. So Haiti was in an area here that hadn't experienced a lot of earthquake activity, so it was a seismic gap. And so when the Port-au-Prince earthquake did occur, it took them by surprise. It was a like, whoa moment. Even though around Haiti there had been a lot of earthquake activity, they were pretty complacent, and then that led to not having very good building codes, and then they weren't enforced very well. In Haiti there was some corruption, and that's why, even though it was a big earthquake, there shouldn't have been 250,000 people die because of that earthquake. And then after the earthquake there was lots of disease because of what we talked about earlier. So it was a sad event in Haiti. All right, that's it for earthquakes. Woohoo!